Hi, and welcome to MSc. In this video, we're going to look at completing the square. So it is important to remember that the reason we want to complete the square is we want to change a quadratic from standard form, y equals ax squared plus bx plus c, into vertex form, which is typically written as y equals a bracket x minus h squared plus k. Vertex form has the benefit of being able to find the vertex of the parabola, because the vertex of the parabola will be h comma k. The vertex of the parabola is also relates to the optimal value, k, which occurs when h is the independent variable. And so it allows us to be able to determine and make optimization statements. Vertex form also allows us to potentially solve for the roots of the quadratic without having to use the quadratic formula, which is an extra benefit of the vertex formula itself. So let's work through an example of completing the square, and I'll try to outline different places where I have found that students struggle with this. So the first thing we have to remember when we're going to complete the square is that I need to look and find out whatever is the coefficient in front of the x squared. If it's a coefficient of 1, then this step is already done for us, and it makes life a lot easier. But when it's not a 1, we have to remember that we need to common factor that value out. And one of the tricky pieces that students want to do is they want to common factor it out of all the values that are there, because when we common factor, we're used to common factor the entire expression. But really what we're interested in is only common factoring it out of the x squared and the x term. So what we have left with here, if I common factor out the negative 2, is just x squared. And then what I'm left with here is going to be positive because I'm taking the negative out, and I'm taking a factor of 2, which leaves me with 6x. And we're not going to common factor it out of that c value, that 7 that's sitting on the end, right? It's not going to be common factored. Notice again, you can quickly redistribute the negative 2 to make sure that you did this right. Negative 2 times x squared is negative 2x. And negative 2 times 6x is going to give me negative 12x. So we did that right. We also don't want to common factor out the x's. There is a common factor of x in those two terms, but we don't common factor that one out, which again, sometimes students find weird because we've been practicing always common factoring as much as we can out of expressions. The next step is also one that seems strange to students. Why does it work? Why are we doing it this way? So our next step is to take a look at this value here, the 6 in this case, the value in front of the x term, and we're going to take that value and we're going to divide by 2. And that's going to give us 3. This might not always give us a whole number. It is quite possible that it will give us a fraction. That's okay. Then we're going to do a second thing to it. And again, it's this double up of process pieces that I think is tricky for students. The other piece we're going to do is we're going to take our result, 3, and we're going to square it. And that's going to give us 9. So we're going to take that 9, and that's what goes in here. We're trying to build this as a perfect square trinomial is what we're trying to do. So by adding plus 9, I have found the perfect square trinomial. But of course, I can't just add plus 9 to this and be done. I can't just say, okay, well, plus 9, close my bracket, minus 7, because that would change the value of this quadratic. It would change the value of the expression. So whatever I've done to it, this plus 9, I also need to undo. So I'm going to minus it as well. So getting to this step can be tricky. We have to remember to common factor out of only the first two terms and not common factor the x. Then we had to look and say I had the 6, I'm going to divide by 2 to get 3, and then square to get 9. So it's always this middle term in front of the x. That's what gets divided by 2 and squared. I encourage students as they're learning this skill to write that off to the side if that helps them remember and keep track of what they've done. At this point now, we have the first 3 terms in the bracket are my perfect square. That's what I want in my bracket. I don't want my negative 9 in my bracket. I want to take the negative 9 out of the bracket. Well, in order to take it out of the bracket, I need to look at what it has, what operations being done at the front. And in this case, it is being multiplied by negative 2. So I'm going to keep my negative 2 out front, and I'm going to remove that negative 9 from the bracket. So there's the perfect square trinomial that I've just set up. And now I'm going to do the negative 9 times the negative 2, which in this case will be positive 18. And then the negative 7 just slides down on the end. So again, what we did here is we took this negative 9 and I removed it from the bracket. And to do that, I needed to multiply by my negative 2 that was out front. That's where 18 came from. What we now have here is a perfect square trinomial. And that's what we want, because I want it to look like x and then a squared. And so what we have to figure out is what goes in here. So that's where we come back up to this 3. And it's whatever your answer was when you divided this part here, the x term in the bracket, divided by 2. So this is going to be 3. And you can look at the sign that you have here. Whatever sign is there is going to slide right down, and that's going to be plus. Doesn't matter it was negative up front. At the very top, you've common factored that negative out. It's now out front. So whatever sign was in front of the x term here slides right down. And that's a bracket. My bracket looks a little messy. Then we're going to do this addition on the end, or subtraction in this case. 18 minus 7 is positive 11. And so I'll rewrite this one last step here, but basically we're done. I just want to rewrite it without that extra red notation there. So this is this quadratic in vertex form. And we can see now that the vertex of this quadratic will happen at negative 3, comma 11. And there's a sign flip as we go from here over to the x value of the vertex. We also know that this parabola will open down. So we can say this has an optimal value of a maximum of 11, and that occurs when x is equal to negative 3. I hope this brief run through of completing the square has been helpful. Don't forget you can always check your answers by using a graphing calculator or an online tool such as Desmos by entering in your standard form and your vertex form, and those graphs should be identical. Please consider liking and subscribing to the channel. Thank you for listening and watching.